Refraction of light. In a medium, light travels along a straight line and it does not change its path. Like we always know, the light would travel in a straight line. This is called rectilinear propagation of light. It always travels along a straight line path. But however, when light travels from one medium to another, when it changes its medium, it bends or changes its direction. Like when light would travel from, say, from glass to air, as long as it traveled in air, it would travel a straight line. But at this interface now, it would change its path. It would not travel along the straight path, but it would bend. This bending of light or changing the direction of light is called refraction. And refraction happens only when light travels from one medium to another. It does not travel in a straight line, but it bends at the interface. At this interface of the air and glass, it will bend, it will change its direction. So this bending of light is called a refraction. So the change in direction of light when it passes from one medium to another is called a refraction. So in this slide we have learned that as long as light travels in the same medium, as long as it travels only in air, it travels in a straight line. Or if it travels only in glass, it travels in a straight line. But when it changes its medium, when it passes from one medium to another, like air to glass, or when it passes from glass to water, when there is a change in medium, it does not follow the straight path. It bends at the interface, at the boundary between the two medium. The next we are going to see is the cause of refraction. Why does light refract? Why does light bend when it moves from one medium to another? This can be explained by the speed of light. Now the speed of light is not the same in all medium. To give you an example, the speed of light in air is 3 into 10 raised to power of 8 meter per second. But speed of light in glass is 2 into 10 raised to power of 8 meter per second. So when light is traveling from air to glass, the speed decreases. There is a decrease in speed. And because of this change in speed, it bends. So the cause of refraction is that the speed of light is different in different media. Now to define a medium, any transparent substance in which light travels is known as medium, like air, glass, diamond, water. These are all matter through which light can travel, and they are all called medium. Now depending on the speed of light, the medium can be divided into two parts, into two kinds. One is called the optically rarer medium. In the medium in which the speed of light is more is called optically rarer, and the medium in which the speed of light is less is called optically denser. To take examples of optically rarer mediums is like air is optically rarer, the speed of light is more. But if you take glass, it is optically denser medium where the speed of light is less. So again, as we go ahead, we will always talk about optically denser, optically rarer medium. Optically denser medium is where speed of light is less. Optically rarer medium is where speed of light is more. Now let's see what happens when light enters an optically rarer medium. For example, from glass, it enters into air. We know air is optically rare and the glass is optically denser medium. So as long as it is in glass, it will travel in a straight line. Now, it should have traveled in the same straight line without changing direction. But when it enters a rarer medium, if this is the normal, here is the normal, it will travel away from the medium, from the normal. So it will move away in this direction, away from the normal. So when it travels a rarer medium, two things happen. One, it moves away from the normal. Second, its speed increases. So when light travels from a dense to a rare medium, like in this case here, it will move away from the normal. Next, let's see when air travels into a denser medium, like from air, when light travels to a denser medium, like air, which is a rare medium, it now enters glass, which is a dense medium. So the light would travel first in a straight line, and on reaching this interface of air and glass, this is the normal, the perpendicular, it should have normally traveled in a straight line. This would have been its original path. But now it is entering a denser medium. So it moves towards the normal. So here are the 2 points. When light travels into a denser medium, number one, it moves towards the normal, and second, its speed decreases. So it moves, this is not medium, this is normal. So we need to remember this as we go about refraction. So when light travels in a denser medium, this here, it's coming down here, it now moves, bends at the interface. At the interface of this interface of the air and glass, it will change its direction. It will move towards the normal. We'll now follow the path of light during refraction. So here's the incident ray, and this is the normal at the point of incidence. This angle between the incident ray and the normal is called the angle of incidence. So the angle between incident ray and normal at the point of incidence is called the angle of incidence. On reaching the interface, the light now begins to bend. This is the refracted light. Now the angle between the normal and the refracted ray, this angle between the normal and the refracted ray is called the angle of refraction. So between refracted ray and normal at the point of incidence is called angle of refraction. So we know now what is angle of incidence is the angle between incident ray and normal, and angle of refraction is between a refracted ray and normal. Let's go over it again. So here in the first case is light is entering a denser medium. Means it is moving from a rarer to denser medium. To dense. A rarer example air to dense example glass. And when it does so, here is the incident light. It moves towards the normal. So there are two things that happens. Moves towards normal, and however we know that the speed decreases. The speed of light decreases. It would have otherwise gone straight down here, but it then moves towards the normal. The second case, the light is moving from denser to a rarer medium, like from glass, which is dense, to air, which is rarer. So here in this picture we can see it is moving from glass, it is in glass, and then now it should have gone straight down like this, but it is moving away from the normal. So when light travels to a rarer medium, two things happen. It moves away from the normal, and the speed increases. We'll now follow the path of light through a rectangular glass slab. So here we have the glass slab, and remember glass is a denser medium. So the incident light, here is the incident ray. At this point it has come to an interface between air and glass. It would have normally traveled along the straight path, but here now it is going to bend towards the medium because it is entering a denser medium. Now again at this interface, it now will bend away from the normal because it's entering a rarer medium. So this is the path of light through a rectangular slab. Now if the rectangular slab wasn't there, it would have traveled along this path. So this distance between the original path of light and the emergent ray is called lateral displacement. So lateral displacement is a perpendicular distance between the original path of light, which in this case is this original path, let me mark it in red, this original path of light, and the emergent beam. This distance between them is called lateral displacement. So we define lateral displacement as the perpendicular distance between emergent ray and original path of light. So this distance between the emergent ray and the original path of light is called lateral displacement. Let me mark that again. So here is the original path of light, and this is the emergent ray. The distance between them is lateral displacement. In both these cases, you have to draw a normal at the point of incidence. So N1, N and N1, these are the normals at the point of incidence. Here we have the angle of incidence, and this is the angle of refraction. Here again is the angle of incidence at the other interface, and this is angle of emergence. The incident ray and the emergent ray are always parallel to each other. So incident ray is always parallel to emergent ray.